to different projects. So I'd like Hani to come up and give the first presentation.
Hello, it's a great pleasure to be here. This is an astonishingly successful conference at the studio, all the people who have shown up. I'm going to go very quickly through 4 actual projects that my firm is involved in at the moment, 3 of which are actually under construction, and 1 that isn't. For us, the designing and construction of tall building is really centered in a kind of, as well as a pragmatic and practical world of building and economics, developer needs and requirements and so on, and societal needs and requirements. It's also based in a kind of theoretical foundation that my firm has, my partner Stature has built up over the years. We are very interested in different aspects of building design and looking at different ways in which tall building can truly merge with city space, with different cultures, with different societies, and get away from a kind of cookie-cutter, generic building design sort of proposition. The first building I'm just going to show quickly is here in Dubai. It's a proposal for the DIFC. It was something we did in collaboration with the Duan Associates and Arab.com. This is a building that really was meant from our design point of view to create a kind of spectacular presence. What would in fact a kind of Eiffel Tower of our time be for a place like Dubai? If Dubai in fact is a kind of crossroad now, cultural and sort of economic engine as it is, could there be a building, an iconic building that stands up against all of the iconic buildings that are going up all the time here? And it's not necessarily just a question of height, it's a question also of a kind of cultural, let's say, DNA and a kind of let's say, reverberation that the project can have in the city space. We began the process really in the project by essentially stacking and binding 4 towers, 4 very slender towers that in fact would bundle around a kind of glass core, and that glass core would be held in place kind of almost metaphysically up above the city of Dubai. The idea was really that we could somehow produce an elegant solution, both engineering-wise and architecturally, by bringing these 4 towers into close proximity, using a kind of inclined elevator system and cores to come up into a body of a building that could then sort of reach up into the sky at a very, very spectacular height. The idea of the building's skin also was kind of critical in a project like this, where we could experiment with or try and in fact create variance and variation across surfaces and get away from a sort of generic curtain wall solution or a sort of solution that is always uniform and unified to create a sort of flicker and a kind of, let's say, shimmer effect on the facade itself. We also wanted to find a way that the building would become sort of, would be noticed obviously, and one of the thoughts really was to work with this red color in a frit pattern glass and produce a sort of, again, kind of spectacular architecture that would sit in the skyline in a very prominent, very compelling way. Here you see the diagrams for the actual notion of the building. The building is sort of 4 slender towers that are then bundled and wrapped, and then the floor plates start to emerge up around the 60th floor, or the 40th floor rather, and then go up into the sort of towers and up through the core, the glass core, and the middle of this building. The programming of the building utilizes these kind of bundling core idea to create the different programs, a hotel program, an office program, and other programs that in fact start to circulate inside of this sort of bundled structure. Here you see a kind of study, let's say, of the fenestration, frit patterning glass, and the combination of both a sort of curtain wall system that is in fact more crystalline in the central core, and then the actual variation of surface on the 4 towers as they climb up the building. And inside the building, at the 46th floor, there's a sort of business center and observatory and centered around this spiral bulb. This bulb piece actually sits in an electronic glass condition up on top of a glass floor. So in fact, from the base of the building, one can look up and see this changing sort of orb up through the very center of the building where the four towers converge. This is just it's obviously a building put into the DIFC. This DIFC area is obviously changing since this photograph was used. And again, the question was how to produce, for at least as a kind of challenge, something that can stand up to the sort of barrage of building styles and eclecticism that is running around in a place like Dubai. And then by night, the sort of notion of the building is a kind of spectacle again, that it would be a luminous tower that would sort of infinitely project itself out into space. And that would come from this sort of this kind of core piece that's being held by these thin building types. This is another project. In this case, I think the goal of the sort of thesis is getting after an engineered elegance. David, in fact, is his group in New York are the structural workers on this project. This is in Abu Dhabi. It's under construction now. It started right away with parametric modeling and parametric tools in terms of trying to understand the form, the floor plates, the efficiencies, the actual building design being established from the use of parametric modeling to, in fact, analyze the possibilities of the form in terms of its different possible configurations. The building is a residential tower, and so we use this parametric initial parametric sketch to look at how we can in fact create interesting balcony conditions, interesting living conditions within a kind of standardized unit. As we sort of froze the model at a certain kind of optimal place, we then started to look at how the stacking would create the interior, exterior parts of this project, a climate like Abu Dhabi's and like this one. One has to be sort of obviously very attentive to what a balcony is used for, how a balcony in fact exists, and the time of year that it in fact becomes occupied. And as we sort of continue to work on this sort of stacked units, we then heard from the client that we were looking for more robustness, more floor plate area, more ample kind of residential units and so on. And we then triparted the parametric model into a three-element piece that in fact spirals up slowly into space. As we continue to study that, different conditions, different nuances of the modeling, to see in fact again what kind of optimal floor plates we get at the top versus the bottom, what are the sort of optimal outdoor versus indoor spaces and so on. The project then sort of resolved itself after a lot of other things into this project. This is in fact now 150 residential units. The first, say, I think the first 18 floors are smaller units that are in fact 6 to a floor, and then as we get up higher, we get to 3 units per floor, and then we get to double stacked penthouse units that are at the top 6 or 8 stories. The building is wrapped in a kind of veil. The veil is in fact an exoskeleton and a roofing system done in collaboration with Front Technologies in Front New York. And the idea is that it of course mitigates and deals with temperature control and the building sort of environmental conditions. But also for us, it really helps us produce a kind of elegance in terms of the form. It is a way for us to in fact deal with certain kinds of optimal glass design, but at the same time retain and achieve a kind of sensual or subtle curvature in the building envelope that would sit on the shoreline of Abu Dhabi on the way in from Dubai. The use of CATIA and in this case with Gary Technologies, we have been, the entire building is in fact parametrically controlled and parametrically modeled. Every single aspect of this building in terms of its skin, its glass, its structural system is all been put into the model and is in fact tweakable to a very fine degree. This came in particularly handy when the client had actually asked us on a whim to add 2 floors without changing the height of the building, which was an interesting moment for us, and a kind of beads of sweat came over everybody. But in fact, in talking with G-Tech and talking with Arab, with front and everyone else involved. And since it was in fact moving through parametric control modeling, it became not incredibly easy, but it became much more facile to begin to understand how the floor height changes and what would do affect MEP and the rest of the building. And in fact, could happen, and did happen. The optimization of the glass in this building is key to its economic viability. The paneling is in fact all single curved and running in a kind of terraced system around the slabs. And again, that veil system allows us to control the curvature and the actual look of the building on its landscape, as well as its utility in terms of the interior shading and so on. Here you see some views of the project as it is under construction in its final design stages. It has a very key kind of aspect to it in terms of the way that we handle the tower, and this isn't necessarily tower design now, but I think it's key to understand for us particularly that we don't think of the towers as necessarily separated from the ground and just sitting in kind of an autonomous fashion. The way these buildings hit the ground, the way they instigate any kind of an urbanism or any kind of a programming at the ground level is key to the success of these buildings in our mind. And this building, in fact, spawns a kind of terrain and a kind of landscape of public functions, restaurants, beach cabanas, various collection areas that are coming directly out of the morphology of the tower as it spins onto the surface of the site. The exoskeleton itself engineered to produce the entranceway, to produce the way in which the entire building is in fact dealt with at the scale of actually entry and the scale of utility at the ground floor. The various components of the building, this parking structure that allows the cars to go into a glass elevator and be then robotically brought down to their parking position is also part of that. The interior spaces actually continue the dialogue. The building, in fact, comes down to produce a series of interesting architectural moments at the ground floor where the combination of both structure and ornaments, let's say in terms of the perforation of glass for patterning, produces certain kinds of atmospheric effects. The apartments are very much kind of villas in the sky, surrounded by glass, and the exoskeleton, which in fact traces its way around the exterior. And this kind of rooftop helipad club area is also key to the building. Here's an interior view. The helicopters, in fact, will be able to park outside and the meetings inside this space. Another tower that is now underway in Korea, also with David and his group in Arup, is in Busan, Korea. This is something we focused on, a kind of what I call kind of symbolic abstraction. It really started as a kind of calligraphic sketch, sort of gesture of the idea being to build a 560-meter tower that in fact has some kind of a, let's say, some kind of a nuance or relatively sort of appropriateness to Korea, to Asia, to this part of the world. So the calligraphic moment, the kind of Sunni painting gesture, spawned three towers as a kind of a notion, three very slender towers. We also look back into the history of tall building, particularly the sort of American condition, the German expressionists over to New York and Chicago, and started thinking really about going back to sort of basics in terms of tall building design, the notion of elegance and the lack of ornament, the notion of kind of infinite spires, much like the World Trade Center towers, and started thinking about how we could in fact develop that thesis, if we could in fact revisit it 20, 30, 40 years another time for now. Here you see the three slender tower design. This has been in fact, thanks to David and his group, modifying a little bit in terms of how we can actually bundle and control the slenderness of these towers. We also have the idea of the curtain wall system draped over the building and coming down and sort of being peeled up slightly to allow for the entrances and the access to these buildings. And here again, the ground floor, how the building actually comes to the ground, how in fact instigates a kind of landscape condition. The atriums and the sort of studies like this one of closed versus open atriums at the bottom, and how the towers can sort of work both between the public realm and the private realm. The elevator cores, the sort of transfer lobbies, and the entire sort of building studied in terms of all of its viability and of course from the client's point of view, extremely key. Here you see an art study for the structure and the idea of outriggers that can trace their way up into the inner part of the tri-part courtyard. The building actually has a kind of, again, a 40-story moment, which is a kind of lifted urbanism of the 40th floor, and then from there the three towers sort of spring up. And we have to find a way, we're trying to find a way to, in fact, again, elegantly tie that without creating a sort of large, robust tying elements. Here you see some views of the building in the design landscape, where the building will sit at 560 meters. It includes large penthouse conditions of wind turbines and other sorts of aspects like that. Here again is another view of the building against the mountainscape. It was really important in terms of this idea of symbolic gesture to find a way that the building could have a kind of dialogue both with the building infrastructure of Busan, which is very, very dense, and the very, very beautiful landscape and seascape condition of the city of Busan. So the building really has to kind of, for us, it has to achieve a sort of a kind of abstract symbolic elegance that plays off these different situations. Again, another view. I know my 20 minutes are up, so I'm going to run to the last one. Yeah, I can see. And the night view, of course, always key to these buildings in terms of perspective. And finally, in Penang, Malaysia, we're underway on a project which I would call eco-iconic. It's a project that we've done, particularly important in this group is Atelier 10, who I believe are here somewhere. And Nico's here, and Atelier 10's kind of, let's say, environmental interest from their practice and how it's come into this building and helped us form the architecture. The building started, again, very gestural sketches for a kind of system of sort of ziggurat-like structures. We actually turned to the German expressionists, to Bruno Taub and others, to look for how we could in fact use crystalline structures once again to achieve that kind of elegance. And then driving those crystalline structures into a 21st century structure that would make sense, looking at different ornamental systems for it. I mean, Malaysia is a Islamic and Chinese kind of hybrid, and as well as Indian cultures, so the idea of bringing these cultures together into some kind of abstract building that would in fact appeal and do all of that at the same time as maintaining a sort of contemporary look and feel. The building is complete with sort of hydroponic planting areas over the roofscapes. These towers go up to large turbine structures that are in the roofs. The building is in fact situated, it's a very large retail complex as well as a performing arts center, office complexes, convention center, as well as a sort of observatory in the mountains of Penang, the two towers that then rise up. Here you see the observatory building and one of the towers. That's the end. Here's the view of the building in its landscape at the back of Penang. If you know Penang, it's a very interesting city. It's Georgetown at the sea, and you go back into the mountain, and then this building will sit against the mountainscape. This is the Performing Arts Center on the left. You can see the use of certain kinds of ornamental glass detailing to create this